All right, this is lesson 2.7, and we are going to be looking at how to sketch the graphs of absolute value functions. So first of all, if you have the absolute value f of x equals the absolute value of x, if we make an xy chart, if you substitute 3 in for x, take the absolute value of it, you get 3. Substitute 2 in, the absolute value of 2 is 2. Absolute value of 1 is 1. The absolute value of 0 is 0. Now when we substitute negative 1 in, the absolute value of negative 1 is a positive 1. If we take the absolute value of negative 2, you get positive 2, and the absolute value of negative 3 is a positive 3. So when we plot those points, we have 3, 3, 2, 2, 1, 1, 0, 0, negative 1, up 1, negative 2, positive 2, negative 3, positive 3. So we end up with a V shape when we graph absolute value because the negatives, we take the positive of those. Okay, so the parent function of the value of all absolute value functions is y equals the absolute value of x. That's the parent function. All other absolute value graphs are transformations and or translations of y equals the absolute value of x. So the graph of y equals x minus h, the absolute value of x minus h, plus k is the graph of y equals the absolute value of x. Trying to move that around, it's not cooperating. Translated over h units horizontally and k units vertically, as shown in the diagram. So the vertex of this equation is at hk. And so again, this is your equation. Now, this equation up here doesn't show it, but the number out front is called a, and that acts like as the slope on the right side of the graph, and we'll talk about that a little bit later, how you use that. So let's look at the graph of, or the equation y equals 1/2 absolute value of x. If we plug in a 6, we would get 3. Plug in a 4, we get 2. 2 times 1/2 is 1. 0 times 1/2 is 0. If we take negative 2, the absolute value is positive 2 times 1/2, we get 1. Negative 4, the absolute value is 4 times 2, or excuse me, times 1/2 is 2. And negative 6, the absolute value of that is 6 times 1/2 is 3. And if we plot that, we have 6, 3, 4, 2, 2, 1, 0, 0, negative 2, 1, negative 4, 2, and negative 6, 3. And so this is how that graph is going to look of that equation. Now, a couple things that I want to point out to you. The general form, remember, is a times the absolute value of x minus h plus k. Well, in this one, we don't have an h and we don't have a k. So those would be 0 and 0. And sure enough, 0, 0 is the vertex of that absolute value graph. And in front is the a. And remember I said that acts like the slope on the right side? Well, if we go from this point to this point, that would be up 1 over 2, up 1 over 2. So sure enough, the slope of the right side is 1/2. On the other side, we go up 1, back 2, because we're reflecting it over that axis of symmetry right here, up 1, back 2. So this does act like the slope on the right side. Now, on this next equation, let's first graph it. And so if we substitute in a 2, we have 2 times negative 3 is negative 6. 1 times negative 3 is negative 3. Then we have 0. Negative 1, take the absolute value is positive 1. And then times that negative 3, you get negative 3. And then this would be a negative 6. So when we plot those points, we go over 2, down 6. Over 1, down 3. 0, 0. Negative 1, negative 3, and back 2, down 6. And there's our V shape. Now, a couple things. Notice on the right side, we do the line on the right side, we do have a slope of negative 3, down 3 over 1, down 3 over 1. And then the other side, it reflects over, down 3, back 1, down 3, back 1. So this acts like the slope on the right side. Another thing to notice is that when you have a negative out front, this V-shaped opens down. So I've made an XY chart for this equation right here, and we're going to just plot those points. So we have 8, 10, 8, 10, 4, 6, 0, 2, negative 4, negative 2, negative 8, 2, and negative 10, 4. And we can see this is a V shape like this. Now, let's use the information we get in the graph. According to this, the H and the K would be a negative 4, negative 2. Now, the reason I say negative 4 and not positive 4 is because this looks like x plus 4. It's x plus 4. But the original equation says x minus h, so x minus a minus 4 would make the positive 4. So whenever we look inside of here, because the original has a negative, it's always going to appear to be the opposite sign. And so your vertex is at negative 4, negative 2. So if we go back 4, down 2, sure enough, that was our vertex. And the slope on the right side is 1, up 1 over 1, up 1 over 1, up 1 over 1. So using that strategy, it's a little bit easier to graph than making the XY chart. So first we identify the HK, or your vertex. It's at positive 1, positive 3, and plot that point over 1, up 3. And then we'll do the slope on the right side. It's a negative 2, so we go down 2 over 1, down 2, back 1, or over 1, down 2, back 1. And then we're going to go back to the vertex, go down 2, but the opposite direction, down 2, the opposite direction, and reflect it over. And there we have our graph. So that is a lot quicker than making the XY chart. Here are a few more for us to practice. So here, first of all, write down the vertex. It's a positive 5, positive 3. That's your H and your K. So we go over 5, up 3. The slope is 2, so we're going to go up 2, over 1, up 2, over 1. Go back to the vertex, go up 2, back 1, up 2, back 1. And there is that graph. And again, this is positive, so notice your V is opening up. So the next one, we have negative 3, negative 2. That's your vertex. So we're going to go back 3, down 2. And the slope is negative 2/4, which is the same as negative 1/2. So we're going to go down 1 over 2, down 1 over 2, down 1 over 2. And then we're going to go back to the vertex, go down 1, back 2, down 1, back 2. So this one will look like that. And the next one, let's see, first let's get the HK. So the H is going to be a positive 3. I don't have a number out here, so the K is 0. So we plot that, go over 3, up 0. The slope is 1/2, so up 1 over 2, up 1 over 2. Up 1 over 2, then we'll go back to the vertex, up 1, back 2, up 1, back 2, up 1, back 2. There's your graph. And the next one, we don't have another value. It's not showing the H value, so the H value is 0. The K value is negative 1. So 0, negative 1 is our vertex, and on the right side, the slope is negative 4. And then we go back to the vertex, go down 4, and back 1, down 4, and back 1. So there's your graph of that one. Here I have a few examples where we actually use absolute value in real life. It's used in science, in determining margins of error, in triangles, in design, in holograms. There's an example here. So it's used in many real life types of situations. The last thing we're going to do in this lesson is we're going to write the equation of an absolute value function when we look at it in the graph. So what we want to do is determine the HK the vertex of it. So this would be -1. So we're going back 1, up 1, 2, 3, 4. So -1, 4. And then we want to look at the slope on the right side. That will be the a value. So this would be going down 1 over 1, 2, 3. So if we go from this point to this point, we're going down 1 over 3. So the rise, your up down is 1. Your run is over 3. So we'll now just substitute those values in. Your a is 1/3, and then it's going to be x minus a -1, so it would be x plus 1, and then plus 4. And there's your equation. And let me know if you have any questions. Thanks for listening.